Good evening, my dear students. Welcome to our class, and we are in the end section of our chapter 3, that is atoms and molecules. And we are having two questions to solve. That is page number 42 and question number 1 I'll read, and I'll help you in solving out the question, the answer for that. If 1 mole of carbon atoms weighed 12 grams, what is the mass in grams of 1 atom of carbon? So, let us do that and start our class. So, if 1 mole of carbon atom weighs 12 grams, what is the mass in grams of 1 atom of carbon? So, let us go through. Mass of 1 mole of carbon atom. Mass of 1 mole of carbon atom. What is that? 12 gram. And a mole of 1 mole of carbon contains how many particles? A mole of carbon contains 6.022 into 10 raised to 23 in number. Then mass of 1 atom of carbon. Then hence mass of one atom of carbon. What is that? 12 by 6.022 into 10 raised to 23. Then we will get the answer as 1.993 into 10 raised to minus 23 gram as mass. Okay. The mass in grams, okay, 1.993 into 10 raised to minus 23 grams as mass. Then, what is the next? Which are small number of atoms, 100 gram of sodium or 100 grams of iron? Given atomic mass of sodium is 23 and iron is 56 units. What is given that we have to write first? So, the solution is there given atomic mass of sodium. Sodium, that is 23 units, and iron, that is 56 units. Is it true? So, 23 gram of sodium contains 23 gram of sodium contains 6.022 into 10 raised to 23 number of atom. Then 100 gram of sodium. then 100 gram of sodium contains how much? Six 6.022 into 10 raised to 23 by 23 into 100. Number of atoms, that is equal to 2.6182 into 1024 number of atom. Okay. Now let us check in case of iron. Okay, let us check in case of iron. Here we got that sodium is 2.6182 into 10,024 number of atom. And in case of iron we are checking now. We are knowing that gram atomic mass of iron is 56 G. Then 56 gram of iron contains 6.022 into 10 raised to 23 number of atoms. Then 100 gram of iron contains 6.022 into 10 raised to 23 into 56 into 100 number of atoms, which is equal to 1.0753 into 1024 number of atoms. So, which is having more? Here 1.0753 and here 2.6182 into 1024. Which is having more? Iron we got 1.753 into 1024 number of atoms. Therefore, gram of 100 gram of the question. What is the question? 100 gram of sodium or 100 gram of iron is having more number of atom. So we can say 100 gram of sodium has more number of atom. Okay. Then 100 gram of iron. And what's next? Okay, let us see what we have studied in our lesson. We studied the law of conservation of mass. What is that? During a chemical reaction, the sum of masses of reactions and products remains unchanged. That is law of conservation of mass. Then what about constant proportion, definite proportion? In pure chemical compound, elements are always present in a definite proportion. Okay, it is telling about the proportion. And what about the atom? It's the smallest particle of the element that cannot usually exist independent. It cannot stay independent, but independent cannot stay independent and retain all its chemical properties. And what is molecule? Smallest particle of an element or a substance or a compound capable of independent existence. In the case of atom, no independent existence. Here it is having the existence, and it will shows the properties of the substance. Then a chemical formula of a compound shows its constituent element and the number of atoms combining each other. Then polyatomic ions, clusters of atoms that act as ions. Then the chemical formula of a molecular compound determines the valency of the element, of each element. Then in ionic compound, the charge on each ion is used to determine the chemical formula of the compound. In the case of ionic compound, okay, and you studied about Avogadro constant and many other things in your this lesson. So let us go to the exercise part. Okay, let us go to the exercise part. You read the what you have learned, that portion. I didn't completed it fully. Already we have studied all those things. Okay, and just going through the exercise. What is the first question? Exercise part. A 0.24 gram sample of compound of oxygen and boron was found by analysts to contain 0.96 gram of boron and 0.144 of oxygen. Calculate the percentage composition of the compound by weight. So let us do the exercise solution. What is given? We have to write first. What are given? What else are given? Mass of the sample. Okay, mass of the sample. Mass of the sample. Then compound. .24 gram. Mass of boron. .096 gram. Mass of oxygen. Mass of oxygen. Zero point 144 gram. Then we have to find the percentage composition. Okay, percentage composition. Percentage composition of the compound. So first, percentage of boron. Percentage of boron. How we will calculate that? Mass of boron by mass of compound. Mass of boron by mass of compound into 100. Can you see the board? Oh God. Into 100. So that is equal to 0.96 into 96 by 0.24 into 100. Will get us 40%. Then percentage of oxygen, that is 100 minus percentage of boron, we will get 60. 100 minus 40, that is 60% as answer. When 3 gram of carbon is burned in 8 gram of oxygen. That is our second exercise. When 3 gram of carbon is burned in 8 gram of oxygen, 11 gram of carbon dioxide is produced. What mass of carbon dioxide will be formed when 3 gram of carbon is burned in 50 gram of oxygen? Which law of chemical combination will govern your answer? Okay. Then 11 gram of carbon dioxide is formed when 3 gram of carbon is burned in 8 gram of oxygen. Carbon and oxygen are combined in the ratio 3:8 to give carbon dioxide. Carbon dioxide. Hence, for 3 gram of carbon and 50 gram of oxygen, 8 gram of oxygen is used and 11 gram of carbon. Is formed. The left oxygen unused is equal to 50 minus 8 is equal to 42. Carbon dioxide is formed. Okay, let it be. And this depicts the law of constant proportion. The law of constant proportions, and we have completed 2 exercises, and we will complete the other in next section. And thank you. Watch the video and study well. Thank you.